In this video, we're going to talk about U notation and recurrence relations. So some of this must be familiar from GCSE, and potentially depending on what you've learned in single maths, you might have already looked at some of this. So if we've got U1 here, what this represents in terms of a sequence is the first term in the sequence. So if I had a sequence 2, 4, 6, 8, 10, and I'll put a ... to indicate it goes on forever. Okay, we could say that U1 would be equal to 2 because that's the first term in the sequence. Then U2 would logically be the second term, and then U3 would be the third term. So going back to my sequence over here, we would say that U2 is equal to 4, U3 is equal to 6. Now, sometimes this is called subscript notation because this little number down here is a subscript. Now, I do just want to compare the subscripts of consecutive terms. So we've got U1 is the first term, then U2 is the second term, then U3 is the third term. Now, if we start with the U2, if you want to go to the next term along, you would add 1 to the subscript. If you want to go to the term before, you would subtract 1 from the subscript. Okay, let's generalize then. So if we have UN, this is the nth term of a sequence. Okay, we don't know what n is, it's just generalizing. That is some term in the sequence, which we'll call UN. Then, if we think about what's going to be the next term along in the sequence, well, we would go to our subscript of n, and we would add 1 to it, so it would be UN plus 1. So UN plus 1 can be called the n plus 1th term of the sequence, or you could call it the term after the nth term. Then let's say we were to go 1 term before UN, then we would have to subtract 1 off the subscript. So we're going to subtract 1. So it would be n subtract 1. So UN subtract 1 represents the term before UN. So you could call UN subtract 1 the n minus 1th term of the sequence, or you could call it the term before the nth term. Now let's look at what a recurrence relation is. So this is an example of a recurrence relation. So that is one name we can give to this. Some other names that we can give to what is written here. You could call it a term-to-term rule. Or it could be called an iterative formula. The main phrase we will use will be recurrence relations when we're working through these videos. Now, if we look here, we have our nth term, and then we have our nth plus 1th term, and it's an equation. So this is an equation linking the nth term with the next term along in the sequence. Essentially, this is telling us what you do to any term to get to the next term in the sequence, hence why it might be called a term-to-term rule instead. So in this case, it's saying you can take any term in the sequence, you then multiply by 5 and subtract 10, and then you will get the next term along in the sequence. Now, the other part of our recurrence relation is you will be given some information about a term in the sequence, usually the first term in the sequence. So in this case, we're told the first term is 7, because we need this value in order to start making use of our recurrence relation. If we didn't have a starting value, I wouldn't know what I'd need to initially substitute in here in order to start generating the terms of the sequence. So let's actually generate some of these terms then. So if U1 is equal to 7, then U2 would be equal to 5 lots of U1, which is 7, subtract 10. So that would give me 25. Then to find U3, I would do 5 multiplied by U2, which was the 25, and then I would subtract 10. So that would give me 150. Then if we were doing U4, we would do 5, which is this here, multiplied by u3, which is the 115, and then we would subtract 10 like that, and that would give you the next term in the sequence. Now, I do just want to think about what is the most efficient way of getting these values out of the calculator. So what you could do is type 7 into your calculator, then hit equals. And the reason I put 7, because that's the first term. Now, once you've hit equals, that 7 is stored in the answer button in the calculator. So what you can type in is 5, and it says UN. So you're then going to type the answer button, and then you are going to subtract 10. And then the idea is if you type that in, that will give you the next term in the sequence. So that will give you the 25. And then if you hit equals again, that will give you the 115. And then if you hit equals again, it will give you the next term in the sequence. This is the most efficient way of using our recurrence relation. And the idea of why it might be called an iterative formula is because this idea of substituting your answer back in to get your next answer, that is called iteration. Now, these recurrence relations can be written slightly differently, okay, because the idea is the UN and the UN plus 1 are consecutive terms. So what you could potentially write instead, which is very similar, would be to write that UN is equal to, so in order to go from the n plus 1 to the n, okay, we have subtracted 1 of our subscript. So then to balance that out, I would go to my second subscript term, the UN, and I would also subtract 1 off its subscript to get n minus 1, and then subtract 10. And then this would generate the same sequence. What also might be the case is that instead of writing u1 as the first term, we might write u0 is equal to 7 instead, as sometimes that will make more sense in contextual questions. So let's have a look at another recurrence relation, a bit more of a complicated one. So we've got it written here. So this time we have 3 subscript terms, un plus 2, un plus 1, and un. So there's 3 consecutive terms, because each time you're just subtracting 1 off a subscript, adding 1 if you're going the other way. And this time you will be given 2 terms to get the sequence started, because the idea is we need to use un and un plus 1 in order to find the next term in the sequence. So in other words, any term in the sequence is dependent on the previous 2 terms, apart from the very first 2 terms, which are just given to you. So if I was using this, we've got u0 and we got u1, so we can find u2 by doing 5 lots of the term before that, so that would be u1, which is the 11. Subtract 10 lots of the term before that, which is the 7, and then subtract 3. And then you would calculate that, and that would give you u2. So we would get negative 18. And then what we could do is use u2, which is negative 18, and it would be the u1, which is 11, in order to find u3. So to do that, I would write u3 is equal to, and it would be 5 lots of the previous term, which is the negative 18, u2. And then it would be subtract 10 lots of, and then we've got the un, which is the term before that. So that would be the u1, which is the 11, subtract 3. And then that calculation there would give you u3. So we would get negative 203.